right, in this second example, we're given the sine of theta equals 1/3. So we know since sine theta equals opposite over hypotenuse, that means my opposite side must be 1 and my hypotenuse must be 3. Now that might not be the exact length. It might be something like the opposite is 2 and the hypotenuse is 6, but the ratios of all all 6 trig functions will still hold true regardless. So let's set up a triangle like that where we have the opposite side of an angle. So over here is 1 and my hypotenuse is 3 if this is my right angle. So to find that third side, we'll have to use Pythagorean's theorem. So we've got a squared plus b squared equals c squared. And my a is 1. And my missing side down here we'll call b. So 1 squared plus b squared equals 3 squared. So 1 plus b squared equals 9. Or b squared equals b squared equals 8. If I take the square root of both sides, I get that my side b is the square root of 8. Another way we could write that is 2 square roots of 2. So that means we know my opposite is 1, my hypotenuse is 3, and my adjacent side is 2 square roots of 2. So then if I'm going to find cosine, cosine is adjacent over hypotenuse. So that's going to be 2 square roots of 2 over 3. For tangent, that's my opposite over adjacent. So I have 1 over 2 square roots of 2. But I don't really like to have radicals on the bottom of my fraction. So what I'm going to do is rationalize that by multiplying the top and the bottom by square root of 2, causing the square roots to cancel out, which gives me square root of 2 over 2 times 2, which is 4. So then my secant, or I should go with cosecant first since it's the reciprocal of sine, is just going to be 1 over sine theta, which is 3 over 1 or 3. My secant is 1 over cosine of theta. So we have essentially 3 over 2 square roots of 2. And then I'll multiply top and bottom by square root of 2. It gives me 2 times 2 on the bottom and 3 radical 2 on the top. And then finally, my cotangent of theta is 1 over tangent of theta. So we have 4 over the square root of 2. So let's multiply top and bottom by square root of 2. The square roots cancel out, and we get 2 on the bottom. And we get 4 radical 2 on the top, which is going to simplify to 2 radical 2. So those are my 6, well, I should say 5 remaining trig functions. And box them so you can see which your answers are. There we go. So then one last problem for you to try. Given tangent of theta equal to 2/3, see if you can find the 5 remaining trig functions for these ratios.